Good afternoon or evening, folks. Thank you for joining us here for another one of our virtual tours of outer space. My name is Josh. It is my privilege to be presenting for you today. We seem to be having some interesting internet connection issues and exacerbated by the fact that my dog's pacing around in here. So if you hear any weird sounds, I promise you he is 100% safe and happy. He just really wants dinner. So with that, it has been a very interesting day here in the United States and something that I think a lot of us are paying a lot of attention to. So for our broadcast today, we are sending it out from the West Coast, out across the US and across the world. It seems like we got folks tuning in from all over the place. For me, I know it is a great chance for us to take a little bit of a step back, a little bit of a breather, and to look at things on a bigger scale. I know that whenever I'm having a tough, stressed out day at work, my absolute favorite thing to do is to go into our planetarium, turn the music on really loud, and fly around in space about 100 light years away from Earth and just see how big and wonderful and beautiful our universe is. So with that, I think we can hand things over. We're going to be using the OpenSpace software today. So if you, like me, need a little bit of a breather, I recommend downloading it, flying out to about 100, 120 light years from Earth, and just giving it a big rotate. When we look at planet Earth, we can see our own beautiful homeworld. For our program today, I'm going to be taking you on a little bit of a tour, but if there's somewhere you would really like to see, by all means, throw the idea in the chat, and I will happily take suggestions. But when we are looking down on our beautiful homeworld, we get to see this bluish area where the sun is striking. We can see this darkish area where the sun is not striking, and these little points of light we see are the lights of human civilization. All around planet Earth, whenever part of it falls into darkness, you can see the presence of human beings indicated in this really wonderful, really beautiful way. The lights of our cities, the places where we cohabitate, shining out into the universe. In fact, this might be one of the ways we find aliens out there someday. If we can see artificial light being generated on a planet or radio signals emanating out from it, it'd be kind of a cool way to indicate the presence of an alien civilization. Being able to sort them out from the naturally occurring lights out there would be a challenging thing to do, but something I think scientists are approaching and very carefully examining how that might happen. So when we look down on planet Earth from this distance, we're kind of just turning into a blue dot. And before we get too far away, I wanted to stop and look at that orange line shooting around our planet. I often say this is the home of all Earthlings. All human beings live on planet Earth, but that's not entirely true, nor has it been true for about 20 years because of this little orange thing shooting around our planet. That's the orbit of the International Space Station, or the ISS. Now, the International Space Station is where a couple people, a small handful of folks, are hanging out away from the surface of Earth. They are not living on the surface of our planet. I guess technically you could say people living in submarines or living under the surface of the water of our planet, but I think when you're getting to that point, you're getting a little pedantic. So these separate groups are the only human beings away from the surface of our planet at any given moment, and they are traveling around our planet once every 17 minutes. Now, every 90 minutes. That's 17,000 miles an hour. That is super duper quick. Now, as they hurtle around the surface of our world, that is the farthest human beings travel into space these days. Once upon a time, we went a little farther, a little beyond the atmosphere of planet Earth, out to the moon, but that's something that human beings haven't done for quite a while. How long? Well, it's been more than 50 years. I think right about 50 years since we set foot on the surface of the moon. That would be 1972, I believe. So when we talk about our moon, that's 250,000 miles from Earth. When astronauts took off and wanted to travel to the moon, they were on board the Atlas V spacecraft, Saturn V, and that took about 3.5 days to get from Earth to the moon. We can do it in just a couple seconds because planetarium software can travel even faster than the Saturn V spacecraft, heck, even faster than the speed of light. That's one of the really fun things about flying around in software. Physics does not constrain you. When our astronauts landed on the moon, they did some exploring. They checked out the surface in incredible detail. The moon might be looking familiar for those of you who live below the equator, but it's upside down for those of us who live above the equator. And when you look at it this way, it is a kind of refreshing view. Things look a little funny, but they look just like the moon looks through a telescope, because telescopes usually show you things upside down and backwards. So when we look around on the surface of the moon, you can see this dark area where many of our Apollo missions landed. They selected these dark mare regions because it was flatter. It looked like an easier place for our experimental spacecraft to land and to explore the surface. Checking out the moon is a wonderful thing to do. And in fact, I believe this morning we had a wonderful third quarter moon hanging out in the sky. So if you have an opportunity, go check it out when the sun is still up. I think morning would be the best time to see it. So looking around here, we get our beautiful moon represents the farthest away thing that human beings have ever set foot on. One day soon, we are hoping to send human beings beyond the moon, out to Mars, but as of yet, that remains a little bit of science fiction. If we are able to do so, it is going to be a big change in human perspective, because we will officially become a species that had visited more than one world, more than the world we evolved on, and that is just awesome. However, colonizing the moon would be pretty cool too, to be a bi-world species living on two worlds at the same time. So if we wanted to check out Mars, it is a quick hop and a jump away from planet Earth. Again, by spacecraft, it would be significant longer, probably about 6 months. A very tricky thing for us to do. But human beings are up to many challenges. We are a pretty awesome, adaptive, and innovative species. When we get to Mars, you can see the surface might look a little smeary, a little smoothed out. Mars does have an atmosphere, and that's largely what we're seeing. You can see this air effect in the OpenSpace software. It gives you that kind of brightish glow all the way around the edge. Now, right down here, you can see a large surface feature. That is Valles Marineris, Mariner Valley, and I think one of the coolest things in our solar system. Now, Valles Marineris is actually so deep. How deep is it? It is so deep, you can see the atmosphere kind of pooling in it. Like a crack in the bottom of the ocean is a deep part of the ocean. This is a deep part of the Martian surface, and we can see more atmosphere accumulating there. The surface of Mars is much less significant than the atmosphere of planet Earth. The atmosphere of Mars is only about 1% the density of what we enjoy here. So on Mars, you wouldn't need a spacesuit necessarily. Well, you would need a spacesuit the second you walked outside. But there's still a little bit of air, enough to blow dust around, but not nearly enough for a human being to take a nice deep breath of. And as a person who is really into breathing, I suggest anytime you go outside on Mars, bringing your spacesuit with you. But looking around on the surface, you can see some very steep slopes going down into Valles Marineris. I believe there was some amazing photography released today that has been blown away by other headlines. But if you have the opportunity, go check it out. Valles Marineris in ultra high detail. I really wanted to stop by that today because it is such an exhilarating view. We stop by Olympus Mons all the time, so I think we can skip that for today. And if you feel brokenhearted, download the software and fly there yourself. So as we are zooming back, this is where human beings have set our sights. Maybe one day we will go beyond Mars, maybe to some of the moons of our solar system like Phobos that orbits Mars, Ganymede that orbits Jupiter, Titan that orbits Saturn. There's a lot of possibilities out there. But this is still our solar system and still relatively close by when we talk about the grand scheme of things. And that's kind of what I would like to talk to you about today, is that grand scheme, a chance for us to look at a bigger perspective than we sometimes do in this show. We're going to fly back from Mars, and as we do, just to give us a sense of scale, I'm going to turn on the trails, the orbits of the planets as they travel around the sun. You can see that red line there showing us the position of Mars as it travels around the sun. The blue line, I believe, is Earth, yellow for Venus, gray for Mercury, and as we zoom back farther, you can see our outer planets, Jupiter, Saturn, Uranus, and Neptune. Now, way out here, this is our solar system. That green orbit could only be Pluto. I didn't turn it on. It seems to have volunteered its presence. But Pluto there is going around the sun too, but on kind of a different plane. Kind of a cool thing to think about. When you look right here, you can see the plane of our solar system. Pluto is off the plane. If all the planets were set on a plate, they'd fit pretty close to the plate. Pluto would be diving above and below the surface of the plate. We got a request for Io from Laura. I promise we will swing by on the way back. So when we look at our solar system, here's a quick idea I really want to hammer home. When we look to the sun, right there in the middle, from our blue orbit, that's Earth, we are seeing light that was emitted by our sun about 8.5 minutes ago. It takes light 8.5 minutes to reach us here on the surface of planet Earth. Similarly, if you were to shine a flashlight at the sun, I don't know why you'd do that. The sun's got plenty of light by itself. It would take about 8.5 minutes for the light to get there. It would have spread out a lot, so I don't think anybody who was hanging out on the sun would be able to see your flashlight for a number of reasons, but they would receive that light, receive that signal at about the same time. As we zoom back, you can see a greater and greater distance. Light travels at the same speed throughout our universe. So by the time light reached Saturn, it would be about an hour old. Gives you an interesting set of scale. From Earth to the Sun is about 8.5 light minutes. From Earth to Saturn is about a light hour. And as we go farther and farther back, you can see by the time we're looking at these outer worlds, it's about 4 light hours out to the orbit of Neptune. And that means, given some simple geometry, it's about 8 light hours across the orbit of Neptune. So from where Neptune is now to where Neptune was a long time ago is about 8 hours from side of orbit to side of orbit. Now, as we zoom back, you can start to see just how big that is. It takes light 8 hours to cross most of our solar system. And as we zoom back more, we had a question, how fast are we theoretically flying? Ooh, I'm going to guess about a light hour, let's see, a light year per minute, depending on which moment I'm hitting it. We're actually going at a logarithmic speed because the farther we get away from the sun, the faster we're traveling. So I guess it's changing at every given second. So it would be an acceleration more appropriately than a speed, but that's more calculus than I want to do in my head at this moment. So I'm going to leave that question for right now. Anselm, that's a great one though. As we are zooming back though, this is the moment I wanted to get to. When that first bright star popped into view, that tells us we are about 4 light years from Earth because the closest stars to our sun are about 4 light years away. So when you're looking at these nearest stars, think about what is just now reaching them. Where if you sent out a TV broadcast in 2016, 2017, it would just now be reaching that distant star. The farther away you go from home, the farther back in time we're looking. So if I travel out 10 light years away, we're seeing Earth as light that is reaching us out here would have left Earth in the year 2011. So the farther and farther back you go, the farther back in time we're looking. The stars that appear closest to us are about maybe 100 light years away. There's a good collection of stars within that. But we often talk about our galaxy as being something much bigger, much greater. Turns out almost all of the stars we see around us are part of the nearby structure of our galaxy. Some of them are part of more distant structures, but it takes an exceptionally bright object to be seen from where we are in space from that far away. As we zoom back more and more, you can start to see just how nearby some of these things are when we compare it as a whole to the scale of our galaxy. So hold on 1 second and you'll be able to see. I promised you this last week and I wanted to follow through. This is our Milky Way, our galaxy. Welcome home. So when you look around here, I saw Brandon was asking, can we see Betelgeuse? We're a bit far back to see Betelgeuse itself, but let's see. If I were to look around here and I were to hazard a guess, I would say Betelgeuse would be in this part of the sky. How am I guessing that? Well, if you look in the direction of the center of our galaxy, Betelgeuse, that's close to Sagittarius. Betelgeuse is kind of in the opposite part of the sky, but not entirely opposite. So over here, I would bet. And if you look at these spiral arms that snake around the center of our galaxy, our chunk of the universe is right between 2 major arms in this little cluster of stuff. And this cluster is called the Orion Spur. Now, the Orion Spur is so named because the bright stars of Orion fall within it. So I'm willing to bet that one of these reddish stars, about 500 light years away from us, although I think that measurement got corrected recently, is Betelgeuse. Now, you think about how far away that is. It's about 500 light years from us, and that's in this little tiny structure. So let's start thinking that through. When we look at the disk of our galaxy, these arms are very flat, kind of like our solar system, as they spin around the center. Turns out from top to bottom, the disk of our galaxy is, depending on what you define as the disk, only about 1,000 light years thick. Now, it's very hard to say with a straight face, only 1,000 light years, because that's still a pretty big measurement. 1,000 light years is huge. But then compare it to the width of our galaxy. So across our Milky Way is about 130,000 light years. So from this side to this side, 130,000 light years is a huge amount of time. Now, I've heard folks say, well, okay, 130,000 light years is a very hard thing for me to hold on to in my head. What were human beings doing 130,000 years ago? 130,000 years ago, I'm pretty sure we were contemplating one of the first migrations from Africa. So to give you a sense of scale, that's a long time ago in the time span of the human species. Now, when we look at our galaxy, it is startling to think that this is just one galaxy. For most of human history, we have thought of this thing as the entire universe. In fact, it was only about 100 years ago, 1920, I believe, when we had confirmation and proof that our galaxy was only one amongst many. So our galaxy is made of 100 billion suns. But when we get back this far, the dots you see are no longer individual stars. They are galaxies in their own rights. Now, it looks like someone spilled a giant bag of Skittles across the universe, but that's not the case. What we are seeing is called the Tully data set. This is the distribution map of the most distant galaxies we have ever seen. Now, the ones that we're seeing now are still relatively close by, only a few million light years away. Let's call it 4 or 5 million light years. When we look at our galaxy, I noticed some folks were saying, what are the blue and red cloudy things made of? That's actually gas and dust inside our galaxy. The blue and red areas are either reflection or absorption nebula. You can see a lot of the dusty nebula-rich areas are close to the disk of our galaxy. That's where material accumulates to form baby stars. Those are the nebulae that give rise to the stars we see. The dark stuff is actually nebula too. It's just where we're seeing it from the opposite side and sort of the light gets absorbed. Now, I'm going to scoot back one more time. Out here, color is going to change. So I really want to call attention to that. When you look at these colors, that's not the true color of the galaxy. We're not seeing like a green galaxy or an orange galaxy. This is a data set. And the distribution, the color we're seeing is showing us how tightly packed stuff is. In this mapping, I believe, we have a slightly different one than I'm used to. So I think oranges are sort of in the middle. And when we look at blues, seem to be relatively spread out. Yellow seems to be very tightly packed. I'm going to say orange is actually pretty tightly packed because we're seeing nice knots of that over here. Now, looking around, we can see that most of the universe is pretty spread out. Big clumps are very rare. I'm going to guess right up here that that is the Virgo supercluster. When we look at this kind of scale, we are seeing the distribution of galaxies in the universe around us, but these are still maybe 100 million light years away. Out here, we are seeing some of the most distant objects we have ever seen. Now, I changed that from most distant galaxies because a lot of this mapping, these are still galaxies. This is the Sloan Digital Sky Survey and the 2-degree field survey, showing us the most distant galaxies we've ever mapped. When we go beyond them, here's where the thing changes. These are no longer the most distant galaxies in green and orange. These are what we call the quasars. Now, the quasars are the quasi-stellar radio sources, quasar for short. These guys are incredibly bright. They are so bright that when we first received light from them, we thought they had to be close by. Imagine looking out your window at night and seeing something incredibly bright. You'd think it was your friend with a bright flashlight shining it right in your window. How scary would it be if you realized that that was something like as far away as the moon and it was still that bright? That would be something very weird, very different, very special. When we saw these things, we assumed they were so bright they had to be stars in our galaxy. And imagine how amazing the revelation was when they figured out that these things are actually some of the most distant things we've ever seen. Quasars, we understand now as baby galaxies, the very first age of galaxy formation. Remember before we were talking about how the farther away you go from home, the farther back in time you look? We're now about 10 billion light years away from home, so we are seeing the universe as it was 10 billion years ago. So this is much closer to the beginning of the universe than today, and there is still one last thing I would like to show you. Way out here, you can see a very strange kind of tie-dye effect. This is the cosmic microwave background, the CMB. Cosmic microwave background is showing us the distribution of matter in our earliest moments of the solar system, right after the Big Bang, a mere 370,000 years. Now, again, 370,000 years sounds like a long time, but in cosmology, it's nothing. This is the first light to pass through our universe. At the moment before this light was emitted, the universe was so dense, light couldn't pass through it. But at the moment where it finally spread out enough, it spread out the individual atoms just enough for light to keep moving, It kept moving and never stopped. This is that light. So by mapping it, we've come to understand the age of our universe in a truly remarkable way. When we think about our universe as a finite thing, I think it's a difficult, challenging idea for a lot of folks. That's great. It is a huge discovery and a revelation for our entire species, but it's also a great reminder of just how big and wonderful our universe is. But I think when confronted by ideas like this, a lot of people pull back and withdraw, and I totally understand that impulse. When we look at this universe, this map of the universe, it looks like we are at the center. And that's something that I think we need to move away from conceptually. It looks like we are at the center because we are making this map from one point in the universe. We look in every direction and we see an equal amount of universe, so we seem to be at the center. But any other observer in any other galaxy would see an equal distance in every direction, and that means the universe is infinite and without end, or at least so close to it that it seems like it would be. Now, that's kind of a mind-blowing and humbling thought. But I don't want to leave you feeling blown apart. I don't want to leave you feeling separate and distant. So to me, it is a wonderful thing to remember that even though Earth and our species are a small part of this universe, we are still a part of it. We are observing in every single direction some of the most beautiful, wonderful, and special things we could ever imagine, beyond anything we could imagine. And the universe just keeps delivering more hits. So with that, I'm bringing us back to our own solar system to see some of the beautiful things people have requested for kind of a final moment of Zen. I know we had requests for some Galilean moons. So I'm going to take us right now to Io, because Io is a really cool and really special one. Whenever I look at Io, it calls to mind that for a long time, we thought Earth had life because it has volcanic activity. And that kind of changing of our surface and introduction of new elements and dynamic energy below the surface was no doubt the source of life. But then we learned more about how life works, and we looked out in the solar system and discovered evidence of volcanoes on a lot of other planets and thought, no, maybe volcanoes aren't quite as important as we thought. Io is a wonderful argument against that. Io is rotten with volcanoes, but still seems to have no evidence of life. Even though it is in many ways like Earth, it's not necessarily a hospitable or habitable place. So Io is a super cool moon. I think we had some requests for others popping up, though. Anybody else? Europa. I can do that. Let's go check out Europa. Now, I often like to say Europa is the coolest moon of Jupiter. That's a pun, because it's a cold moon, because it's covered in ice, but it's not actually the coldest moon, I don't think. It's receiving a fair amount of energy from Jupiter, and that activity is actually changing the surface. A while ago, we had an opportunity, I think with Mikey, to examine the surface of Europa, and he gave us wonderful, amazing explanations of exactly what's going on the surface. And I will say openly, it blew my mind. There are so many mechanisms, so much changing on the surface. I would do you a disservice if I tried to explain too much of the details. But parroting his words, whenever you see one of these changes that looks like a pattern, like it's a repeated cycle over and over again, it really is. What we're seeing is a crack, a change in the surface, sort of shear, that's been caused by motion with Jupiter. When Jupiter pulls on Europa in this rhythmic way, it shatters the surface in that same kind of rhythmic way. So we get to see Jupiter inscribing these elegant kind of doily-like patterns on the surface of one of its moons. Okay, Fakir asked, what software are we using? This is OpenSpace. It is a super cool planetarium software, and it's one that you can actually download for yourself. A wonderful thing to do. I'm poking through the questions. I saw one a little earlier from Ratna asking, how do we locate all these galaxies without going there? Well, we use telescopes, really, really big telescopes that point off in all directions and receive light from these galaxies. Overwhelmingly, astronomers use light to study the universe around us because it's one of the most useful tools we have. In fact, it's been the only tool we have for a very long time. Recently, though, we are branching out into different chunks of physics to grant ourselves more tools. So you may have heard about gravitational waves, a huge deal, and maybe one day in the far future, we'll have a chance to use gravitational waves to map structures. Let's see. We saw a request for another Galilean moon, Callisto. I will take us... Oh, I didn't load Callisto. Let me see if I can pull that up in the tree. I should always load Callisto because Callisto is a really cool moon. Okay, so inside our solar system, let's go check out planets. Let's go check out Jupiter. Let's check out Jupiter's moons. And let's target Callisto. Okay. So when we head out to Callisto, just a hop, skip, and a jump, Callisto is the farthest out of our Galilean moons. And because of that, it doesn't get as much hype. It does not get as much credit. But it's one of the easiest ones to see from Earth because it gets farthest away from Jupiter. It's got the greatest angular separation. When you look at Callisto, you can see a surface just covered in craters. Especially compared to Europa, you see tons of craters. It's also a very evenly colored moon. You don't see a lot of variation other than impacts where stuff is hit. We think Callisto is probably one of the best records of what's happened in our solar system over time. This is an ancient surface, super duper old, and because it changes so little, we actually get a wonderfully preserved set of information. So one day I really hope we can do some in-depth geology. I don't even know what you'd call it. We call it aerology on the surface of Mars, but for Callisto, Callistology? I would have to make up a new word for that. Okay, let's see. Where else should we go, Mary? We're getting close on time. Can we see Saturn? We absolutely can. So heading out to Saturn, this, again, is a long trip from planet Earth. Every time we send a spacecraft out there, we are talking about something that's going to take, I think, about 7 years to get to Saturn. So that is by no means a small commitment. The last major mission we sent out there was Cassini, and Cassini did a wonderful job. Now, I'm going to give a brief shout out. If you check out OpenSpace, they can probably direct you to a presentation happening, I think, this Friday, all about Saturn and its rings. So if you are watching any of the OpenSpace folks, Corey or Mary, a link to that would be absolutely awesome because the rings of Saturn are amazing, and they are going to be doing some very up-close examination of those rings and showing off some of the really cool structures like propellers that we see forming in there. Saturn's rings are dynamic and an absolutely fascinating place to study. Okay, zooming back just a little more, do we have any other requests? Let's see. I see more Europa. Okay, I think that might be it for us for today. I'm going to take us back into planet Earth. And as I do, I think it is a wonderful and powerful thing for all of us to remind ourselves that when we talk about places like Earth, we have found a few places that have some characteristics in common. But Earth is something so far unique in the universe, something really special. It is the place where life has arisen. And when you look to the words from astronauts who have examined our planet from high above, they're struck by the overwhelming awareness that the divisions and stuff that we've placed here on planet Earth are completely artificial. And we are stuck on this planet together. So I think for now, it behooves us to appreciate that fact and to be aware of just how precious life is and how much we mean to each other, and to really take it upon ourselves to take care of each other as much as we possibly can. So with that, I'd like to thank all of you for joining me here for a broadcast and a chance for us to experience the universe around us. Thank you all, and I hope wherever the rest of your day finds you, you have a great rest of this little turn here on planet Earth. Thanks again.